Third application of Gauss's theorem is electric field intensity due to uniformly charged conducting sphere. Sphere is hollow or solid but must be conducting. A is uniformly charged sphere is represented by this yellow color. Charge on it is plus q. Then we have to calculate electric field intensity at point P. Electric field intensity at point P. Therefore, consider a Gaussian sphere B represented by dotted blue color of radius r, because distance of point P from the center is r. Therefore, B is a Gaussian sphere. Capital R is the radius of sphere A. Small r becomes radius of Gaussian sphere. Now, sigma is surface charge density, charge per unit area. इलेक्ट्रिक फील्ड इंटेंसिटी हमको P पॉइंट का निकालना है, तो हमको एक गॉसियन इमेजिनरी स्फीयर कंसिडर करना पड़ेगा जो कोने B है ब्लू कलर से। इनिशियली पॉइंट P के बाजू में एक एरिया ds कंसिडर करेंगे और उसमें से फ्लक्स निकालेंगे। तो क्या आएगा देखो, फ्लक्स पासिंग थ्रू एरिया ds d phi equal to electric field intensity E and area vector ds. But E and ds are parallel to each other because normal to area ds represent the vector ds. Therefore, dot product E or ds, E ds cos 0. Cos 0 is 1. This equation gives flux passing through area ds. Now, what flux passing through entire closed surface? If we consider small area ds here ds on sphere, large number of small element ds, then what is the flux passing through this all ds is obtained by integrating above equation. Therefore, total flux through Gaussian sphere, total flux through Gaussian sphere phi equal to closed integration of d phi. Put the value of d phi E ds. But again E is constant on the surface of sphere. Distance from the center is same. Therefore, E is outside. Integration of ds. Summation of this small element on the surface, and this represents the area of sphere, and area of sphere means area of Gaussian surface 4 pi r square. Therefore, phi equal to E into 4 pi r square. Equation number 1. Another equation of flux is according to Gauss theorem by Gauss's theorem. Total flux through any closed surface is phi equal to q enclosed. Q enclosed is q by epsilon naught. Equation number 2. Now, left hand side of equation 1 and 2 are equal. Therefore, 1 equal to 2. We get E 4 pi r square q by epsilon naught. Therefore, equation of electric field intensity for outside point 1 by 4 pi epsilon 0 q by r square. R is a distance of that point from the center of sphere, not from the surface of sphere. Shortcut. Suppose this is a uniformly charged sphere. Then what is the electric field intensity at outside point P? R is greater than R. E out 1 by 4 pi epsilon 0 q by r square. Put q equal to sigma into 4 pi r square. We get sigma r square by epsilon 0 r square. Then what is electric field intensity at on the surface? Put r small r equal to capital R. We get 1 by 4 pi epsilon q by capital R square. In this equation, r cancel, sigma by epsilon 0. Right? Then what is electric field intensity inside the conducting sphere? Inside the conducting sphere, no electric lines. Therefore, electric field intensity 0. Or another matter, suppose we have to calculate electric field at this point inside. Then enclosed that point by Gaussian surface. This is now Gaussian sphere. No charge enclosed by Gaussian sphere. Charge enclosed by Gaussian sphere is 0 because charge is resides on the outer surface of sphere. Q enclosed is 0, therefore flux is 0. Flux 0 means E 0. This is a surface. Then for electric field intensity inside point is 0, and for outside point is inversely proportional to r square, represented by this graph. Outside point, inside 0, maximum on the surface.